Patrick ROTZETTER, he says about himself that he's a very passionate learner and especially about AI and machine learning, but actually out of his 20 years of experience in digital banking projects, he will give us a real expert showcase of how you can use actual cloud technologies to provide chatbots or conversational agent for smart banking. Am I right? Are you with us?
Yeah, thank you. Can you hear me?
Yes, pretty fine. The floor is yours.
Thank you very much. My name is Patrick ROTZETTER. I'm from Switzerland. I'm working for IBM in Switzerland, by the way. I'm a serial learner. I'm passionate about machine learning and AI, and specifically about real-life use cases for AI in banking, but also in insurance, for example, and other industries. I've been writing some articles, blogs, and I'm also animating an AI community. So you can always connect with me on Twitter or LinkedIn later on. My talk today will be a little bit of a summary of some articles that have written on Medium, for example, or LinkedIn, and also at the end there's a reference to a short video where we are showing the prototype chatbot that we did with one of my colleagues at IBM on Facebook Messenger, but I'll come back to that a bit later. So what will be the agenda today? So I'll give you a little bit of background why this talk. Then we'll go through a few challenges that we can see for virtual assistants or chatbot in the regulated industries like finance, like insurance, like banking. Obviously, we need to make sure that the chatbot stays within the limits, right? You cannot just say anything to anybody, like it's the case in most cases, but in banking, that's even more the case, right? You cannot just chit chat with a customer. Then I will go through some experiments I've done we're using Spacey, that's a Python library. It's quite interesting to see how natural language understanding can detect entities in a simple mail or in a simple message. And then we'll go through an experiment I've done on using multi-cloud strategy if we want AWS and Azure, and then go through some conclusion. So I'll try to be fast. I have only 30 minutes, but I think we should be okay. So a little bit of background. Since some time, together with my colleague Jorge, we were talking about how to use chatbots to enable new client onboarding in banking, right? We see a lot of discussions about chatbots or voice assistants giving us the ability to ask for our account balance or to do cash transfer or things like that. But these are relatively simple transactions, right? So we wanted to go a bit deeper than that and see how a customer could interact with a bank, give some information about himself, and then have a kind of a natural dialogue and go a bit away from the button-based chatbots, right, using natural language. So I'll come back to that in a second. So what are the challenges for virtual assistants in financial services? First of all, we don't have a large data set that we can use to train a model that will automatically engage the conversation with the customer, right? We usually cannot record a conversation between a client and the customer, right, for obvious confidentiality reasons. So there's no data set at all, right? It's not like we have, for example, movie dialogues that we could use, right, to train a chatbot. We have books, theaters, and so on. But for banking, we have basically no data set. Then there's a data privacy issue. We cannot publish conversations between a banker and his client. That's quite obvious. We're also talking about a very narrow and specific domain, right? So if we speak about onboarding banking or onboarding in insurance, which is pretty much similar, this is very narrow, and this is very difficult to train because that could be absorbed, right, in a very general model that is, for example, trained on Wikipedia. And then you're talking about banking, right? So it's a bit too narrow compared to a general model. And finally, the industry, financial services, is strongly regulated, so you cannot just you have to really manage what the assistant is replying to the client. So we're not saying it's not possible, but it needs to be managed, and that's why we wanted to go beyond the hype, basically. It's also interesting to see what types of assistants are available, or what types of chatbots, right? We have chatbots that can answer questions, that can ask you about how are you, and so how is the weather. We reply, it's sunny today. So they are not very useful, but they are used for R&D or some fun website. Then we have, especially in banking, we can see a lot of button-based chatbots or assistants where there's not much of intelligence. Basically, you can click 1, 2, or 3, depending what you want to do. So there's almost no natural dialogue, right? So it's basically a form that has been implemented into an assistant. Then we have general Q&A chatbots, where it's been trained on Q&A data sets, where you can ask questions, you get an answer. When was the French Revolution, for example, and things like that. It can be used for help desk purposes, for example, in the IT, or can be used for education purposes, and it's quite useful. Then we have a fully machine learning based trained models based on the latest transformers models like GPT-3. I'm sure you heard about that, right? They are quite impressive. They can generate text, they can reply to you, they can even replicate yourself, they can generate poetry and so on, right? So very impressive. But again, not quite sure how much it's going to impact the development of virtual assistant in banking in the future, but we'll have to investigate that. Then we have hybrid chatbots, which is a mix of natural language processing or understanding and business rules. We need to implement business rules to make sure that we are compliant with banking regulations, for example, because we cannot, just a stupid example, we cannot propose a bank account to somebody that is less than 18 years old, for example, in Switzerland, or this kind of thing. So this needs to be managed. What is the typical architecture of a dialogue system? It's not new, right? It's based on some paper published in 2000. So first of all, you have the user input. It can be speech-based or it can be text-based. Doesn't make a big difference. If it's speech-based, then there will be a component to automatically recognize speech and convert to text. Then there is a natural language understanding component that is really here to understand the intent of the customer. What does he want to do, or what does he want to say? What kind of action does he want to do? And then identify slots. For example, I want to book a flight to New York. So the intent is booking a flight, and the slot is New York, because that's where I want to go. Then there's a component called Dialog Manager. Dialog Manager is really here to manage the dialogue. So based on the context, the virtual assistant needs to know what is the next action, right? So if, for example, you're booking something, the next action might be to pay the ticket, for example. So, and we'll go back to that a bit later. And also, you can interact from a virtual assistant with a backend system, and that's what we will be showing as well. The backend can be a database, for example, to look for some information. It can be a Another machine learning model, that's the small experiment we're going to demonstrate, where basically it's going to call an Azure REST service, right, to look for a product recommendation. So this is the typical architecture of a virtual assistant. Now let's go to something a bit more practical. So I'm gonna show you a couple of experiments we've done using Spacey. Spacey is a Python library, natural language processing library that can integrate a lot of different models. It can integrate the latest transformer models. It can do entity recognition. It can do part of speech tagging. You can do dependency tagging. You can also add your own rules, and this is what I'm going to show. So I'm going to show two small examples that could represent a typical conversation, right? In banking, for example, could have a chatbot using Messenger and the client saying, okay, hello, I'm interested to open a trading account for trading purpose with an initial investment of 100K USD. Thanks a lot, Patrick. So if we process this sentence through Spacey, Spacey will detect that, for example, 100K USD is money, right? So that's really where the statistical model comes into play. It will automatically detect some specific entities like money, like investment, like trading. I'll come back to that, how this is possible. And another example is, I was thinking that maybe you want to send a mail to your favorite e-commerce site and say, okay, hello, I would like to order a notebook with a 16 gigabyte memory and 256 gigabyte disk. How can we use Spacey, right, to try to understand the intent of the client in a form that is maybe more natural than clicking buttons, right? So let me show you a little bit of code this time. So here, this is maybe, don't know about the audience if you are technical or not, but I just want to show a little bit of experiment that I've done here on using Jupyter Notebook. So here you can see the sentence, hello, I would like to order a notebook. So this sentence I've read into the notebook. Now I'm going to process the sentence using Spacey and try to see what kind of entities the Spacey has detected. So like in this case, it has detected that 16 gigabyte is quantity, 256 gigabytes quantity as well, and Patrick is a person. So that's quite impressive already. Without doing anything, the Python library is automatically detecting a few entities. Now, we can also show this in a more visual form, right? But unfortunately, the problem with this model, it doesn't recognize, for example, a disk, right? It doesn't know what a disk is. And this is quite important because we want to order, of course, a laptop with 16 gigabyte memory, but we also want to have a disk with 256 gigabytes. So if I want to interpret what the customer is trying to tell me, I need to understand also what the disk is, for example. So for that, I can add my own business rules. Saying, for example, that a disk is a part, right? It could be a different part, but okay, in this case, we'll use disk. And also francs, it's not a quantity, it's a currency. So we have to put some rules in addition to the statistical model to say franc is in fact a currency. So if I do that, I can add some rules to my model. And then if I go again through the model, you can see that now the francs is really identified as a currency and disk as a part, right? And then you can see that visually. I wanted to show that because it demonstrates a little bit how chatbots can work really in the background. So you could also build a chatbot fully with Python, going with a Spacey, for example, and build your own chatbot fully using Spacey. But I'll show you how we can do it later with AWS. So this was a short example with laptop ordering mail, but we can also look at the example that is more banking oriented. For example, let's look at a simple sentence that I'm gonna send to my chatbot. For example, I'm saying I'm interested to open a trading account, as I said earlier. So let's process the message here. Let's see what entities my application has detected. It has detected that, which is already great. It has detected that 100K USD is in fact money, right? It's money. And again, Patrick is a person, so great. How does it look like visually? Like this now. Since I'm in banking, I need to add some business rules. For example, I need to identify the subject of the request. And for that, I'm gonna say, okay, if I encounter something like trading account, I know that we are talking about an account. If I'm encountering a word like investment, I know that we're talking about invest. And then that's gonna help me later on to identify the intent of the customer. So here I just added my own rules, and then you can see that now we can identify the account entity. All right. Now I just want to show you another short experiment how to detect what the customer wants to do. Does he want to open the account or close the account? Because obviously I don't know, right? Because the model cannot really understand what the user wants to do. So one way to do that is, for example, compare the similarity of what the customer is telling me with predefined sentences. So in my case, what I will try to do is compare the sentence I've received from the customer, or the intent, with a predefined intent. So for example, I'm comparing what I had before with the sentence, I want to open the account. Now, the similarity is 0.88. So let's see if I compare it to I want to close my account. So the similarity is lower, luckily. So basically, using similarities, I can try to guess what the client wanted to do. In that case, he wanted to open the account and not close it. So luckily, we have a higher similarity with opening an account. I can also compare with the weather is beautiful today. Just as an example, you see the similarity is lower than the previous one. Luckily, it's a 0.71 instead of 0.86, right? And what about I want to close the window, right? Because maybe I want to close the account, but I want also to close the window, right? Which has nothing to do with what we're talking about, but let's see how much we get. So again, luckily we get 0.81, which is lower than 0.88 with 86. Okay, it's not an exact science, but I just wanted to demonstrate how we could manage smarter conversations using Spacey. Okay, that was about Spacey. Just a little bit of observation is that depending on technology you're going to be using, depending on which version of a library you're going to be using, or if you're going to use Azure Text Analytics and not Spacey, you might get totally different entities, right? So your virtual assistant might behave totally differently. So already at the beginning, when you do architecture decisions, you might take decisions that might impact your whole life cycle and might impact the future of your virtual assistant as well. So one needs to be quite careful on choosing the right model for his business context. Now, the last experiment I wanted to show you is a prototype chatbot that we developed using Amazon Lex. I'll show you. So Amazon Lex will help us to identify the intents. Like I want to open an account, I am a Swiss national, I am 42 years old, and so on, this kind of thing. Getting slot values. Then we will manage the dialogue with the customer, manage the context. It's quite important to manage the context because we don't want to ask the customer twice what is his name and 3 times where it's coming from. So we need to really keep the context between different questions and answers, right? And we want to be as natural as possible, meaning that the user can go back and forth between different questions and answers, right? So that's why the dialogue management is so important. We're going to use AWS Lambda, which is serverless infrastructure, and we use Python again to code it. And in the backend, what we've done is we implemented a very simple product recommendation engine, who is in fact recommending some type of bank account based on some characteristics of the client, right? Based on nationality, based on different things, marital status, based on employment and this kind of thing. So very primitive. So let me show you a little bit how it looks like. So this is Amazon Lex. You can see here the various intents. So the first intent is to open an account. Then, in fact, we have a little bit misused the framework. Usually, you would define only one intent. You would say, I want to open an account, and then you would put a few options here, and then that's it. But what we've done, we have decomposed the dialogue into multiple intents to be able to jump back and forth between different sequence in the dialogue, in fact. And what we've done before all this, sorry, this is a bit small. Before coding the chatbot, we have really designed the dialogue in detail. So we have a full script with different states. So for example, hi, how can I help you? Then the input from the human is, I need the information on opening an account. Sure, then the first question I need to ask, at least in Switzerland, is, are you a resident or a national? Do you have a work permit here or not? And this kind of thing is quite important. Then we need to know if, for example, you are non-national residing in Switzerland, we need to know the permit type to be able to open an account later on, and so forth, and so on and so forth. So very important is to have a very detailed design of the whole experience, and also to implement what we call the finite state machine, which means that for every single state here, we need to know what happens in case the customer is going to say A or B, right? So that we have a very well-managed dialogue. So if we go here, I don't want to go through the whole thing, but just giving you an example, right? So first is the hello. So then the reply to hello is quite simple. It's coded here. Hello, I'm your virtual assistant. So that's all great. Then I'm going to say, I want to open a new account. What happens is that then Amazon Lex would compare this sentence with these different variances of what we call utterances or intents. And this is the same thing that I was showing earlier on using Spaces. So Amazon will compare Amazon Lex will compare my sentence, my input here, and check if this is something similar. So obviously here that's easy because I have the same kind of example. I want to open an account, and based on that, it will answer, sure, are you a country, a resident, or a national? So that's the answer I get from the chatbot, and then I will say I am a resident. Based on that, he will ask me where am I from, right, and so on and so forth. What is interesting to see is that let me just go to the right place here. Okay. Here, for example, I have a slot, right, that will capture if I'm a national or a resident. And then if I'm answering I'm a resident, I need to be able to keep this information for later. And to keep this information, that's where, in fact, we have to code some function in AWS Lambda to keep, okay, I'm not going to go through the code, but it's just to show that, in fact, there's a bit of coding to be done behind the scene to keep track of the context, of who am I talking to, or of what is the next step. So, for example, here you can see that I'm checking if the answer is national or not. If it's if it's national, then since I'm in Switzerland, then the country will be Switzerland, and then I will ask the next question based on that, saying, what is your country of residence? Because you can be from Switzerland but not live in Switzerland. That's the reason why we're asking this question. So that gives a bit of flavor of the prototype. The other thing we did at the end of the dialogue is that, based on all the answers we got from the user, we will try to recommend a type of bank account, right? So here I'm saying, great, given your profile, I can recommend the account silver product with 37% of probability that we will suit your needs. So this is almost a different topic, but just to mention that what happens is that our assistant here will call a web service that we've developed using Microsoft Azure Machine Learning Studio, which is a simple classifier based on I can show you a little bit the data set that we use to train the classifier. So we have generated synthetic data, right? So we have one record per person saying that, okay, this person is single, is in an age group 18-30, has a child, is executive, and so on and so forth. And for each person, we have defined a potential product. So product 1, 2, 3, 4, and we have 14 products more or less. So we have trained a classifier, and this classifier is then published through an API, and this API is then called from our virtual assistant to get a potential product for the client. So that's a bit of the prototype I wanted to show you. And yeah, I mentioned that already. What are the key elements for smart conversations? Really detailed scripting, right? We need to be able to capture a lot of different actions from the customer and define the next state based on the actions. We need obviously to be able to keep the context between different sentences so that we can really manage the dialogue, which is quite obvious. Yeah, I mentioned about the product recommender based on a simple data set here that we implemented in Microsoft Azure. And here you can see this is the end result. In fact, this is Facebook Messenger was connected to AWS Lex, right? And you can see the same dialogue that I was showing earlier in Facebook Messenger. This is available on YouTube, by the way. So you see, sure, are you a country resident, national? I'm a resident, and so on and so forth. All right. Maybe 30 minutes. So I'll go through my conclusion, right? So what what we're saying is that full machine learning based models might not yet be fully usable for financial services, right? Because as we said earlier, this is strictly really regulated. But we have to see in the future, maybe we could fine tune these models to implement very smart conversations. We still need a mix of business rules and hard-coded dialogue management to keep the context and personalize the dialogue, as you've seen, and also to comply to regulations. Now we can hear a lot about new NLP models like GPT-3 or T5. We cannot, I mean, obviously we can use them for language understanding. And in fact, in the small experiment I've shown earlier on Spacey, we were using a transformer model, but it doesn't help us so much for the dialogue management, right? Because we don't have enough banking dialogues or insurance dialogues that we can train on. That was it. Thank you very much.
Patrick, actually, it was very interesting to see how it works for a domain where you have zero knowledge to do a chatbot. Personally, I was working with chatbot when I was in my bachelor, and it was just conversational agent, and everything was there, you know, full % machine learning. But here you have business rules and so many other things to think of to make it work.
We have lots of constraints, right? So yeah. It doesn't mean it's impossible, but it needs to be managed carefully.
Yeah, legally it must be a nightmare. Plus, there is a lot of difference, right?
So in fact, what happened is that the dialogue has been designed by my colleague, who is an expert in banking onboarding, right? So you need obviously the domain knowledge, that's for sure, right? A lot of domain knowledge, and then you need some technical also skills, but that's maybe even easier. I don't know.
So I don't want to monopolize you, so I will invite everybody to give you a grade. What beautiful star in the pool, and then maybe we can start with a Q&A with the public, because we have some question in the chat. So let's start.
Should I continue sharing or stop sharing?
You can stop sharing anyway. We are on the screen, the two of us. Okay. So I have a question here from Giza about the language variability. So how would you handle that? I saw, for instance, in the AWS example you were showing, you had a bunch of sentences saying the same thing in different way. So is that something done by hand? How does it work?
Well, if you do that with AWS Lex or Google Dialog, I believe, or Microsoft Lewis, right? This is the right name. This is handled by the tool itself, right? So, so I don't know how they're working exactly, by the way, but my assumption is that they are working with similarities I was showing in Spacey, and trying to calculate the probability that two sentences are similar. But what I know as well is that in some cases you can also manually, right?
Yeah, fine-tune.
Fine-tune based on the interactions you have with the user. You can say, in fact, this sentence corresponds to this indent. I know that's working like that in Google, for example.
Yeah, I understand. Building on that instead, let's talk about the Azure Classifier, because you showed you did have some kind of data set there. So are these anonymized data? How did it work? Can you tell us?
It was pure synthetic data.
Pure synthetic data.
That we invented together with my colleague. We just randomly generated 500 lines of data with, hopefully somewhat realistic, not that much. That's why, in fact, the model is not working that great. But if you look at it, right, with 14 products, if you divide 100 by 14, you should get a probability of 7.
Yeah.
8, whatever. I can. Sorry about that. But you saw that the probability was 34%, right? So it's better than random.
Yeah. It's an achievement, indeed.
It's an achievement. But the idea is really because that's the famous bootstrap problem, right?
Yeah, of course.
When you start to build the recommender systems, you don't have any data. So you need to start from somewhere and then slowly train and retrain.
Yeah, of course. So that's the biggest stop probably now. What do you think will be the next step for the future?
Yeah, that's okay. Okay, I'm a strong believer in federated learning, by the way, and the people who know me think it's an obsession. So, so I strongly believe in because I mean banks or insurances they might be big, but they might be smaller as well, and they don't even have enough data anyway, even if they are big, right? So probably the future might be sharing the data in a confidential mode, right? And then maybe collaborating to get better models, although that might not be so popular because you don't want to share the model with the competitors, but at least from a theoretical perspective, that looks attractive.
So we need some co-petition here, otherwise we won't move on,
right? Yeah, we need
right?
some, yeah, exactly. Yeah.
I see your point, yeah. And are you involved with research in universities or like outside of the professional scope to help yourself with this? Is it possible? Or does this help at all?
I'm not involved. I'm just trying to... I didn't understand the sense of the question because it can be...
So I mean that this is a very specific professional field, like where everything is legal and whatnot. So are you involving other research areas? So other, you know, the innovation funnel. So nothing in-house, but also outside.
Well, okay. What we're doing, in fact, is with my colleague again, we founded the AI community, right? So where, in fact, we try to bring a network of people together to share their experience, not sell their products and services, but to really share experience, practical use cases, challenges, not only from banking, but can be from any other domain. So we have a community on LinkedIn, and it's public, by the way, so anybody can join. And we're trying to have speakers from research universities, from industry, right, to just discuss about different topics. Yes.
So yeah, as you were mentioning, next step is to spread the knowledge.
Yeah, it's to spread the knowledge, discuss about practical use cases. There's a lot of hype, right? Sometimes you need to go beyond the hype, right? And just to see what's feasible, especially given the scarcity of data, right? So we've seen that for banking, chatbots might be a bit difficult, right? But we have lots of other examples where we don't have enough data.
And building back on what you were mentioning, putting together little realities, knowledge, don't we have a big difference in between different states about regulations and how, like, for instance, the offers varies according to the countries and whatnot? What do you think?
Yeah, that's...
That's going to complicate.
On top of everything, yeah, I didn't even go that route, right? I was just focusing. That's why I was mentioning Switzerland all the time, because we were a bit, since my colleague and I are from Switzerland, we know more or less the regulation in Switzerland. But then you're right? When you go to EU or non-EU or UK, US, you have totally different regulations. Then you need to adapt, right? And of course, you have not only the language issue, because you, for example, your assistant, whatever, needs to speak different languages, but also different regulations, right? So policies. Yeah, that makes it quite complicated. It's not impossible, but it has to be properly designed. That's in fact the message, right? Proper design.
Okay, I think we have probably another little bit of time. So just a curiosity from my side, since you have such expertise with different technology on the field, how mature do you think they are? How much had you to fidget with them to obtain the result you got? So if you have any...
How much time? Yeah, you know, I started being interested in the field 5-6 years ago, so I need first. I'm a self-learner, so but since I was a software engineer at the beginning, it was a bit easier. Right? But then I started six years ago to learn. So that's been a long journey, right? To learn different aspects of machine learning and AI, right? And then when we started discussion about that with my friend, maybe it took us like a couple of months to come up with the prototype, right? But we had to think about the design quite intensively.
There is a bit of friction from the opening an account on AWS and getting to the prototype.
Yeah, there was. Yes, I mean, but you know, the most challenging part was really to come up with the right dialogue. The technology was okay, not the limiting factor. We could have used. In fact, I used AWS because I could write in Python, so that was easier for me.
Yeah, definitely. Understandable.
So, yeah. But the limiting factor was more about, like I said, the regulation.
The user interaction.
And find the right dialogue.
Yeah, I see.